Okay, the first thing I would like you to do is to pause the video and have a go at task number 1. Write down the next 3 terms in the following sequences. Okay, moving on. So sequences are all about finding patterns between either the numbers or pictures, whatever you've got, where there's something that can be continued by trying to find some sort of relationship between one term and the next. Now, a sequence can be generated using what we call an nth term rule. This letter n in the nth term rule is a letter that we use to represent a certain position in the sequence that we're interested in. So if I was interested in the 7th term, the 7th number in a sequence, then I would choose n to be the letter 7. If I was interested in what the 11th term in a sequence was, I would be interested in what happens when n is equal to 11. Let's have a look at this example. What is the first, second, and 100th term of a sequence using 3n plus 1? Okay, so just get my pen. So this bit of algebra here, this 3n plus 1, this is what we call our nth term rule. It's a little rule involving the letter n. And all we need to try and remember is that this letter n here represents the word position. Okay, so n is our position number in our sequence. So for this question, what is the first, second, and 100th term of our sequence? We've got 3 things to work out. If we start with the first term, what this means is, if I'm interested in the first term, then that is position number 1, which means that I need n to equal 1. If I was interested in the second term, which we will get to momentarily, we would be interested in what happens when n is equal to 2. And for our 100th term, you might be able to predict what's going to happen here. We would be interested in what happens when n is equal to the number 100. Okay, so let's start with our first term, n equals 1. So let's have a look at our rule, 3n plus 1. So what we're going to do is we're going to replace n with the value of 1. So 3n, what is 3 doing to n if it's next to it? Well, what it's doing is it's timesing n. And then we've got a plus 1 at the end. But remember what we just said. So 3 times n plus 1, we're replacing n with the number 1 for our first term. So I'm going to delete n and replace it with 1. And then we can work out our answer. So 3 times 1 plus 1 gives us an answer of 4, which means that 4 is the number of our first term. What about for our second term then? Well, for our second term, we do exactly the same thing, but this time we replace n with 2. So remember what our rule means. It means 3 times n plus 1. 3 times n plus 1. But on this occasion, we're going to replace n with the value of 2. So I'm going to delete n and replace it with the value of 2. So now I can work out this calculation. 3 times 2 add 1, that would equal 7. So 7 is my second term. Finally, for my 100th term, exactly the same idea, but this time n is going to be the value 100. So we do 3 times 100 plus 1. All comes from the same rule of 3n plus 1. 3 times our value of n plus 1. In this case, we have an answer of 301. So our first term in our sequence is 4, our second term in the sequence is 7, and our 100th term would be 301. Now, it doesn't really look too much like a sequence because we've only picked out certain positions in this particular sequence. Let's have a look at another example where we can actually see our sequence a little bit more clearly. So here's our next example. Use 5n minus 3 to find the first 4 terms of a sequence. So we're not told specifically find first term, find fifth term, find 10th term, things like that. It says we need to find the first 4 terms of a sequence. Well, the first 4 terms of a sequence will start with the first term, and the second term, and the third term, and then the 4th term. Beyond that, we'd have our 5th term, 6th term, and so on. But we're interested in the first 4 terms, so we want our first term, our second term, our third, and our 4th. And on this occasion, we have a brand new rule, which is 5n minus 3. And remember once again that this letter n here represents our position number. So n in this case is going to be replaced by a different number, and those numbers are going to be based on our 4 positions: first, second, third, and fourth. I won't go through all of them, but if we look at our first term, what does that mean? Our first term means that n is going to be replaced with 1. If I move along, let's have a look at the third term. What do you think that would mean? That means that n has got to be replaced with the value of 3. Our second term, n is replaced with 2. Our fourth term, n is replaced with 4. So let's get into working out the first 4 terms of our sequence. Okay, so let's start with our first term. So here's our rule, remember, 5n minus 3. What does that mean? That means 5 times whatever n is. 5 is in front of n, so it's timesing n. And then we're taking away 3. But for our first term, we are going to replace n with the value of 1. So let's delete the letter n and replace it with the value of 1. So now we can work it out. 5 times 1, take away 3, gives us an answer of 2. Let's move on to our second term. So our second term, might be able to guess hopefully, is when we do 5 times 2, take away 3. So looking at our rule, 5n minus 3, we've replaced n with the value of 2. It's the same position that's changing each time. Where that n was, that's becoming a new number each time. But we've still got the times 5 and we've still got the take away 3. 5 times 2 take away 3, work it out, will give us an answer of 7. Moving on to our third term, so when n is equal to 3, so we would have 5 times 3 take away 3. That will give us an answer of 12. And finally, working out the fourth term, we've got 5 times 4 take away 3. And that gives us an answer of 17. And hopefully, because we've actually got consecutive positions here, first, second, third, fourth, hopefully you can actually see the pattern in our sequence. 2, 7, 12, 15. It's going up in 5s. Hopefully you would be able to predict what the 5th term is going to be, even without doing the working out. if we keep on going up in fives, we should be able to generate all the rest of the terms that would follow. But that is how you use what we call the nth term rule to generate a sequence. What I'd like you to do now is have a look at the following 5 rules. And for the following 5 rules, I'd like you to find the first 4 terms. So you're going to generate a sequence of 4 terms, the first 4 terms, so the first, the second, the third, and the fourth, for each of the following rules.